Okay, let's get going. Anybody want to share what they were able to get done last week or attempt?
Yeah, so I tried training in the same way that Abhishek described in his public notebook in his script, but I wasn't able to get the same score that he reported, and in fact, my model quickly overfitted because I didn't really freeze. Well, he didn't. I didn't freeze any of the layers, and as far as I know, like he didn't either. And so, right, so that didn't really work for me. But because I didn't use his code as it is, I kind of just incorporated what I think he did into my own code. So I can't say for sure, like where I went wrong. So that didn't really work. And then I started to try other things, such as looking at the performance in each discourse type. And also, I also try to use the discourse type as a target instead of as an input. So for that, my model is trained to predict both the effectiveness and the type of the discourse. And yeah, so I'm still experimenting with that.
And what was the first thing you mentioned you were trying, like to what? No, I understand. The second thing you mentioned is trying to predict the discourse type and the effectiveness, right?
Yeah.
So you have like a two-headed classifier, meaning one which predicts 3 classes and the other one which predicts 7 classes.
Yeah, because like you know how Ato mentioned, if anyone's tried just training like one model per each discourse type, I was thinking about doing that, but I don't think I really have enough GPU hours to do that. So I thought, okay, maybe then I'll try to train the model to recognize the discourse type instead, and to see if it helps sort of in the same way. Yeah. Yeah.
But why do you say I mean, wouldn't it be cheaper computing wise to just compute the effectiveness per discourse type, because then your data that you would process per model is reduced by the size of the data per discourse type, and then the only other problem left to do is kind of at the end combine all the outputs from the 7 different models, right? So, but each model will be doing less work because it's only being trained on a fraction of the data set.
Yeah, I guess like even though the number of model increases, the number of samples decreases per model, right? So yeah, so maybe it might not lead to an overall increase in the number of GPU hours used.
Yeah, because I mean, of course, if you're trying to do it in parallel, then I'm not meaning if you're trying to run the models, if you have multi-GPU, then I don't know can't talk to that. But if you're just using a single GPU, then I would think in general it would be more work to do what you're trying to do, right? But at the same time, I guess the thing I'm thinking about is you have 7 models, but each of the models is handling less data. So it's kind of hard to say which one will be faster compute-wise.
Right.
But what was the first thing you tried? You said in addition to trying to predict both compute and, both discourse type and discourse effectiveness, there was something else you said you tried, right?
So the other thing I tried was to train like Abhishek, and I didn't, so that didn't work. So I used debutta large and then a batch size of 2, and I used, similar learning rate of like 10 to the -6, and yeah, it overfitted really badly actually. Debutta large is a very large model, and so the training loss just kept decreasing, and at some points the validation loss just started increasing, and so I had so at the end of 5 epochs, my local validation loss was like 0.7 something, but when I submitted it, it went over 1. So I think it was overfitting. So yeah, so I just wonder like how people can get scores in the in the 60s. But yeah, I wonder like if anyone here has achieved that score. Yeah, it'd be interesting to know like exactly how you train your model to get a score of like 0.6 something.
Yeah, actually, I mean, I had followed some notebooks which were public to get, fairly low score with debutta v3 large, and just simply doing combination of SA plus, the thing I had shared, I don't know, a couple of weeks back of joining the SA. Now, last week I tried the approach that of embedding the discourse type in the essay and then trying to predict. I got the training done, but because the guy has the code and I followed that, but the inference is something that I'm struggling with, because in inference, you have to again mask all the non-CLS tokens to -100, and I haven't yet figured out a good way to do that. And I'm kind of working on that, and that's taking much longer than I thought it would. I kind of kept making some mistakes and stuff. So I haven't been able to make even the first submission based on that. And I think I was also tempted to switch, and maybe in the next day I will to try what Arto had also suggested last week, which is see whether something similar to, I think if I recall correctly, what I had suggested was something similar to last competitions thing, that is, in addition to providing a single example of a discourse type, throw in a few more examples of discourse type in the tokenization along with the essay, with the same, potentially with the same effectiveness, and see whether that gives you any benefit. So I was going to try and switch to trying that maybe in the next day or two, and if that doesn't, and see whether that gives any better results. Arto, I think that's kind of what you were suggesting as one of the options to try, right?
Yeah. I think I thrown in like a bunch of things to just from the top of my head last week, and I haven't tried any of that yet, really. But yeah, that was one of the things I was thinking. Like if we give some examples of but basically try like a few short scene, something like that. So you give an examples of discourses with corresponding effectiveness, and like to show the model what would be like an effective discourse of that type, and what would be ineffective discourse of that type.
So would you include both in the tokenization, meaning a positive and a negative example, and as well, or just positive examples?
I think it's make to me it seems to make sense to include both positive and negative with the corresponding labels, so that basically something like a few shot what is done at few shot inference, but to use it during fine tuning, like to make model learn to use this information. So, but yeah, that's kind of, I think it's kind of a bit raw idea, but so, when doing inference with models like GPT-3, for example, right, we can provide like few labeled examples, and then formulate the prompt in a way like we have maybe few labeled example, and finally our example of interest, and then a blank space where the label is expected to be generated, right? So
I haven't used GPT-3, so that's kind of what is. So actually, you're saying provide examples and corresponding labels. So you would, so just thinking aloud as you're saying, so you would tokenize the example of interest, then multiple examples, both positive and negative, and the corresponding token, corresponding label.
I'm looking for some nice illustration of that at the moment.
Yeah, because I haven't used GPT-3, so I'm not familiar with the method you just said of providing examples to the model and then asking it to classify. But yeah, so if there is some example, that would be great.
Yeah, just a moment, I will fetch.
Yeah, because something similar, because I'm again just beginning. That's one of the reasons to try these Kaggle problems was the whole familiarity with Hugging Face and its interface. So I'm right now struggling with the approach that another person had suggested of embedding the discourse type in the essay and then with a CLS and N token within each discourse type. So I was able to train doing that. And, he obviously uses, or not obvious, but it's kind of in another Transformers lessons on Hugging Face itself. It's explained that you could use -100 for cross entropy loss to prevent the model from classifying or counting any losses because of any other token other than the CLS token, because you're only interested in the CLS token. Now I get that, but what I'm trying then in inference to do is to do that same thing by sticking in -100, but without the labels being present, and I'm kind of struggling with that right now. So, I have to figure out all the dimensions and get the -100s in the correct places except for the CLS token. So there isn't a neat example for that. So I'm kind of muddling my way through. Similarly, I was just curious if there is an example that I can follow, then I can learn to do it once and then I have it in my head.
I was trying something similar in the previous competition when I was using some specific tokens to indicate that this should be treated as used to. I will look at the code I have, and maybe if it can be helpful for this case, I will share it. Yeah, let me share my screen. I have the GPT-3 paper opened, and it has probably some examples of few-shot inference. Oh, just a moment. Okay. Yeah. I guess. Can you see my screen now?
Yes.
I will zoom in. So here is like an example where you prime the model to so here you see the part of the input is a bunch of questions with answers. And finally, we have, so we want to models that to do question answering. So we provide like Q, A, Q, A, Q, A, Q, and finally A, And these examples are essentially intended to like show the model what do we want, what task do we want to perform, So we want like questions answered here. And basically we want to fill in this underscore with an answer. You see here we have like the place where underscore is, we want that filled in. And I was thinking of doing something kind of similar for this competition, but by providing an examples of efficient and inefficient discourses. So basically, it would be, we don't need to formulate it like a generative task. That's just for GPT-3, it's a generative model, so we need to make it generative, right? But in our case, we can basically have like our target question, then like a separator token, and then a bunch of examples with labels, to show what an efficient and inefficient discourse would be. But I'm not sure if that's the like most straightforward thing to try, because it's like
but it could be an interesting variation, because one of the things I see is even in the last competition, right, that the one reason I got a little bit of a boost compared to many others who had used similar models, not similar models, but so I guess were ensembling models, because I was able to use a different approach and a different model, and that really helped give a little bit of a boost. So to the extent that your model and or approach is not correlated to the other approaches that you're ensembling, it actually works for your benefit, right? So in that sense, in fact, that is the sense in which I was wanting to try these two different things of what you had suggested and the other approach the guy had suggested of embedding the discourse, not so much because even if that particular model is not your best performing model. If its approach is not correlated with the other models in your ensemble, your performance improves if you're using an ensemble.
Yeah, true.
Right. So that's what is motivating me within the week left. If I can get any one of these other approaches to work, then, because if you're just using the same tokenization approach with just variation in the models, that's one thing. But if you're using different tokenization approaches in the different models, I assume that would yield to a better performance when you ensemble the model.
Have you guys looked at the notebook named Huge Ensemble?
No.
Okay, I'm sharing the link in the chat here. So this is the notebook that I used, and it's giving a pretty good score of 0.611.
How many models does he ensemble?
They are taking in 4 big models: Debata base, Debata large, Robota large, and an ensemble of Debata base models that are 5. So 5 plus 6, 7, 8. So it's currently 8 models that they are currently combining. And yeah.
Are all the models tokenized the same way, that the inputs are tokenized identically or just slightly differently with not major difference?
They are, I think so, slightly different. I've shared the link in the chat. I hope so. Yeah. They are slightly different with respect to the padding that they have used, the correlation, and with respect to embeddings, I'm not too sure exactly how they have approached it. Yeah, let me share my screen.
The only variation in the tokenization that I've seen are the 3 approaches. One that Arto just suggested, one that I'm fiddling with but can't get the inference to work, which is embedding the discourse type in the essay. And the third one is, what everybody has tried, which is just simply combining the essay text with the discourse type text and trying to, get that as your input. Has anybody seen any other tokenization input variations? Jack, Arto, or you, Mayank, have you seen any other approaches to input generation other than these 3 that I rattled off? Yeah, see the first one where he says concatenates discourse text, separator, essay text, that's kind of what I've seen most people do.
Yeah.
Of course, the model varies. I think the model I was using, the guy was using is is to use the mean averaging output and having classification head on top, but with mean pooling. Yep, apply mean pooling on the final hidden states. That's very similar to what many people have done.
Are there any numbers how much applying mean pooling instead of CLS pooling helps in this tasks?
No, I haven't seen anybody post a good kind of analysis of
Yeah,
what's the thing
with
called?
respect to applying the mean pooling here, yeah, they do not have a specific number of as much as how much it would affect your chances of the embeddings which are being taken here. So that's one drawback to this, because they haven't compared it with the with mean pooling versus without. So we cannot.
Yeah, I know, for example, in contrastive learning setting, the mean pooling performs much better compared to CLS pooling. I mean, like, for example, in like topic embedding, like this, yeah, how it's called, the BERT models that are sentence BERT, right? As BERT, it performs much better with mean pooling compared to CLS pooling for most cases. And also, I've seen this mentioned in some papers where there is like multimodal contrastive training, but in like this language model papers where they report results on superglue and stuff, they do not do that. So I'm wondering if it really helps or and how much it helps. It would be really interesting to know. But
yeah, I think so. They might have given it in the paper, which they, I think so, have written with respect to the database, or that might be in.
Oh, I've read the BERTA paper, and the thing here in the pictures below, the diagrams in this notebook that you see, it's the diagrams from the BERTA paper. They have this kind of specific head where they do the
So this is the paper that you were.
yeah, and I think the diagram of that the head they use, it's in the appendix. Oh, so this Liberta with 3, so that's another one.
Yeah, I think so. I might not have that. Yeah, let me take a quick look.
Yeah, so the motivation they give in the Liberta paper to use this head with attention, it's slightly different. They basically provide the absolute positional information there, because in the model, the Liberta uses a relative positional information. But they do mention that you can use any kind of information for the final this head layer, but they did not provide any like examples of other information you can use for a query. So here you can see that in the final layer, so this thing they call enhanced mask decoder. They have the query vector. It comes not from the output of the previous layer, but from some external source, right? And what they used in Liberta v1 was just absolute positional information. So it's not really some kind of very specific information ingestion. They just said that we figured we are using relative positional embeddings in the model, so we need to indicate for the model the absolute positions somewhere. And so what they've done, they used this position embeddings as an input here for attention computation, right?
Yep.
So yeah, so that's like somewhat different, right? But yeah, you can use like any kind of input here, and that's also another interesting thing. Like, what can you use as an input for the to compute the attention? Basically, we can use, instead of mean pooling, we can use like a learnable attention pooling in this kind of style, right? As opposed to the attention pooling that was used in a previous competition. I think Jack showed the notebooks using like a attention pooling head, right?
Yeah, I'm also using it here.
Yeah,
well.
but that would be a different approach compared to this one. There it was like that kind of attention was more similar to the attention used in earlier like Bogdanov attention or something like that, right? In the pre-transformer LSTM sequence to sequence models, stuff like that.
Yeah, agree.
Oh, the one other thing I want to add is one of the models that in terms of input variation that I was asking, actually one model that I used, which gets a fairly good score, actually adds the topic information as input as well after classifying the topic, and he adds the data from the 2021 competition. So that might be something else to throw into the mix with respect to the ensemble.
I think Jack was doing a similar thing, right?
Yeah, I was doing some grouping using the topics, but I'm not using the data from the previous competition. Right, do you think many people are doing pseudo labeling for this?
I don't know many, but the one guy who I was kind of using his pre-trained model, Liberta V3 Large, he was doing that, and that got him in the range of about 0.62 something.
Is this
So I was
the
just
comprehensive
that,
guide?
I'm sorry?
Is this like from that notebook with the title Comprehensive Guide?
Yeah, that
Okay.
guy. That guy is using topic modeling and pseudo labeling by using 2021 data, where the problem was slightly different there. The problem there was, in fact, to do what one of the tasks that you're doing, Jack, which is to predict the discourse type, but he uses the data available there. He's generated previously the topics in that competition, and he uses the same method here to generate topics as well. And
does he provide the like comparison with and without pseudo labeling? What is the difference in
no,
this?
no. Unfortunately, none of these do any kind of ablation to say, hey, here is with topic, but he does mention that the reason he is doing the topic labeling, and in fact, if you recall, when I went through that notebook, he also does this, and we spent some time, right, like where he does the tokenization using tuples instead of just bringing all of them together, and that seems to, he says, based on his experiments offline on Colab, the tuple approach seems to provide benefit, but he doesn't say how much. So those are the two things in terms of input preparation that I've seen be different from what everybody else is doing. One is trying to throw in the topic as part of it, and the other is to provide the input as a tuple. Although and this is what was interesting, he does mention that the tuple approach seems to give him some benefit, but that's interesting because we saw from what Arto was showing, right, at least Deberta models don't take the second or whatever the second input of the tuple. If it is treated as a second sentence, then they don't seem to care. But still providing the input as a tuple to tokenizer seems to be better than just stringing it all in one string. And I don't know why he claims that that is better. He does say that he sees better results, but I haven't tried it with and without that trick to see how much you benefit from that trick.
So I've just seen that. Is he using max length of 384? Or is that changed later when he just before his string?
Only in the notebook that he is that particular notebook that he has made public. I believe in the V3 large step model that he has actually pre-trained offline, I believe there he has gone to either, I believe it's either 512 or 1048. I am talking from memory, so I could be wrong, but he is definitely not using 384 in that case. He has increased it substantially.
Okay.
At a minimum to 512, but possibly to 1048.
I actually thought the allowed values are like just like it can either be 512 or like 1024. So it can actually be anything. Or...
Yeah, no, 1024 is what I mean. Not I meant to say 1024. In some other cases, I've seen people use 2K 2048. That's what I got mixed up. He uses 512 or 1024.
Okay, thanks.
When he went to the V3 large model that he trained on Colab offline, he has increased the max length. Yeah, I'm particularly also in this case interested, although there's not much shared publicly, but I'm very interested once the competition closes of seeing the results of the efficiency competition, because for once it'd be interesting to see how people have approached that problem, because the ensemble approach that even Mayank shared, right? I mean, by the time you get to 8 and 10 and 15 models, I mean, that's great, but it's just huge training and compute even in inference sync. Whereas the people who are on the leaderboard of the efficiency competition, I'd be very interested to see what they are doing, because I think in those cases, you would, I'm guessing, but probably you would have to be creative in both in every step of the way. So you'd have to be creative in the inputs you're generating to the model, So the tokenization approach and the details of that would be very relevant. And I'm guessing that the modification in the model, because you know, unless it's a very simple model, I'm assuming that they'll not be using ensembles if they are any of these large models. So the way they tweak a model to get the efficiency would also be very fascinating. So that would be very interesting to see the results. But what is fascinating to me is that at least last time I checked, many of the people who are on the leaderboard of the unrestricted competition are also in the top with respect to the efficiency. Which means that many of the people on the top are not necessarily, although I could be wrong, you know, are, I guess, not ensembling or finding creative ways to ensemble which don't just suck up compute.
Is there an other table for efficiency based?
Yes.
Okay.
Yes. If you actually look at the leaderboard, if any one of you can pull it up and share. Let me see whether I can. Let's see. But my screen is behaving somewhat. Can you guys see my screen or?
No.
Yeah, it seems to be having some. I'll stop sharing. Can anyone of you?
Yep, let me share it. Yeah. So here's the leaderboard.
Yeah, if you go to the overview, and click on that efficiency price evaluation. No, well, yeah, you can do that too. There, the efficiency leaderboard is linked right below in the efficiency metric. Not that one, the one, yeah, there. Yeah, so this is the efficiency leaderboard, which is different from the standard leaderboard. But this Darjeeling tea guy is, I think, up on the top. So you see Darjeeling tea, SKT, BKK, team hydrogen, and the letter combination H and Y, blah, blah, blah. And if you go back to the overall leaderboard as well, you see Darjeeling tea is number 2. And the H and Y and N and stuff are number 1 right now. So those two teams are pretty high. And BKK and SKT are also number 6 and number 8. So you can see that, you know, people who are doing among the top in the regular leaderboard are also pretty high up with a few variations on the efficiency leaderboard, which I think is fascinating because in this case, you know, many of the guys are coming up with results which are also extremely efficient while being the best results as well. Right. So that's something I am very interested in seeing once the results come out. my guess is that there is a lot of engineering involved in how they optimize every step of the overall process. That is, at least the two key steps are the model itself and then the input preparation. That could be others. Any other thoughts? Arto, were you able to get the thing? What was the term you were using? Like adapters thing done, or any luck working on it, or you were busy?
I just had some time today to work on it, and at the moment it seems like yeah, the performance is better with the regular fine tuning. So I need to see how to improve. Yeah, it might be like some just learning rate tuning, stuff like that, to get the adapter scene perform on similar level, hopefully. But yeah, I will try a couple of things, but I don't really have time to during the week. So
yeah, the one question I had, do you and I wasn't sure and I didn't have the time to poke into it, are there good example notebooks that have implemented the AWP for language models?
Oh, I think, yeah, I'm not sure if about the code introduced in that paper that is named adversarial weight perturbation, but how do I call the Diberta repo has their SIFT code open source now, so there is an implementation. It's not a notebook, but it's a source code of their what they use to fine tune the Diberta model with adversarial stuff. I can share.
This is on the Diberta GitHub.
Diberta, just I can share a link to the corresponding folder.
Yeah, because I was just looking for examples. I haven't searched GitHub, but I was searching to see whether there are some good examples of, because that was the other thing I wanted to try, right? You had mentioned, and I think it would be interesting, especially given the overfitting of very quick overfitting of its adversarial weight. But that was another thing I wanted to try, but I just did not see any kind of simple step-by-step approach to what you do, and most of that kind of stuff is on the vision side.
I've sent a link to the chat, and I also have this code. I can maybe I will make a notebook, some notebook that is cleaned up with what I've used for my experiments. I'm not sure if it will, like, how good is that implementation, because as I've told before, I had like a mixed result. Sometimes it helped, sometimes it didn't help. But I can share that as well. But I will need to like clean up some stuff there.
Yeah, no, that'd be great, because at least I looked on the web for any, anybody even explaining it on YouTube, or anybody kind of, usually it's fairly easy to find these things so one can follow along. And so I understand the concept, but any kind of implementation gets into doing it for vision and not for any of the language models. So yeah, if there is, thanks for sharing the pointer, and if you can regardless of the results, if you can share the notebook after cleanup, that would be great. That can serve potentially, so I can at least learn what the approach is for implementing such a thing in language NLP.
Yeah, I had implementation for FastAI framework and for Hugging Face trainer. So I will check that. Maybe try to run it on this competition, and I will share the notebook. But I think this Swift code in the Berto repo, it probably is more robust, so
okay, yeah, I'll take a look
and
at that.
it's also it should be like you can read it, follow it's documented, and
okay, no, that should help. Yeah, even that Swift code thing, because I haven't, and I think Steve Robert had posted a link to a set of lectures, but that talk about the concept in detail, 5-6 lectures and even notebook, but all of it is vision related. I mean, I can, obviously try some things based on that, but I was like, hey, it would help immensely if it was directly related to NLP, because then you don't have to worry about, oh, do I do this, do I do that, or how to handle all the detailed questions that you come up with whenever you try voting techniques. So.
I found a notebook called Fast AWP by Jun Koda on Kaggle, but I haven't really tried it out, so I don't know if it's any good.
Is it for NLP at least, or is it for vision problems, or do you know?
So it's for that competition, NBME score clinical patients notes. So I imagine it's for NLP.
Oh, okay.
Yeah. And so a question I have is like, do you guys use gradient clipping often? And like, if you do, what kind of like, how do you choose the value for it?
I usually use with norm of 1, and yeah, I basically usually I follow whatever is used in the paper or something. Some models have like a larger values, like 5 for some TTS models, and
Okay.
yeah, sometimes it is helpful to maybe make it a bit smaller, like 0.5, but that's just whatever is used by the authors of corresponding paper, and usually they do use gradient clipping.
So is it as simple as like the smaller the value, the less likely the model is to overfit? Is it something like that, or it's more complicated?
It's not really has to do with overfitting directly. I think it's more like a gradient noise, right? So when you clip the values, if the gradient was very large and you were supposed to make a large update in that direction, you will make the smaller update instead. And that's
okay.
I think it's more like making the updates less noisy.
Okay. Thanks. And do you
yeah, the
tend
one
to...
other place
yeah.
where I've seen it used, well, it's more from the point of view of the gradient explosion type of issue. Reasons to that is what I've seen as the explanation whenever they use it.
Yeah, and do you tend to use the trainer provided by Hugging Face when fine-tuning their transformers? Or like, have you, I guess, if you don't use their provided trainer, have you found that you can also get this sort of similar performance?
That trainer isn't like, there isn't much fancy stuff if you don't use like multi-GPU stuff like that. It's a very basic training loop with like linear warm-up, decay, how do you call it, the schedule by default, plus the weight decay parameter groups.
Right. Are those important though? I mean,
the weight decay parameter groups, I think that might be, it depends on what value of weight decay you use. It's quite often you use like a very small value or no weight decay at all, and obviously in those cases it's not important. But if you in your task the weight decay helps, and then I think it's probably quite important to use this weight decay properly. But
what about parameter initialization? Do they do any special initialization?
Parameter initialization.
Yeah,
I don't think there is any.
Okay.
No. I think there is nothing specific for parameter initialization, and that's basically when you create the model, the parameters are initialized. So even if you don't use their trainer, but you use Hugging Face models, in that case you will have like the same kind of initialization, right? And yeah, if I don't think they do something like fancy there. They just use default initialization.
Okay.
Wouldn't it be as part of the config setup?
I think it's just part of how the like a model for specific task is implemented. So for example, if you use like auto model for sequence classification, they just add the linear layer on top of that transformer, and that's where the parameters are initialized. And yeah, that's it. So and if you use like your custom head, then you initialize the parameters yourself, right?
So one should be able to get similar performance without using their trainer, right?
Yeah, that's that's not. They don't have any kind of like fancy stuff there that isn't like a common practice. So
okay, thanks.
But to your point, they do have. I've seen a whole lot of knobs for choosing warm up as well as choosing learning rate decay, including I've seen cosine decay and rather than just linear. So they have lots of knobs by which you can tweak those things. So if you don't exactly do that corresponding to what's been done in the paper or in some reference, then you might see different results, Jack.
Okay, thanks.
Or also we can, I think, so choose the initializer that we want for the mid layers of the transformer with respect to the Xavier or He, or there are other initializers too. There is some research in this area which alludes to the fact that if your weights in your neural network have been initialized, which have a smaller delta when compared to the final weights that you would get after your model has been trained, So if that's the case, if the delta is small, then you may get a higher performance versus if your delta is large with respect to the initialization and the final updates after the back propagation and all the process, the gradients have been accumulated and passed through. And if the delta is large, then yeah, you may not get the sort of performance with respect to the middle layers of the transform model. So yeah, this is a specific case which I saw in a research paper with respect to not just transformers but CNNs as well. So yeah, that may be one thing to keep in mind while trying to initialize your middle layers initially.
Okay, thanks.
Okie dokie. Anybody else have any inputs, thoughts, comments? If not, good luck. Last week, I think we have probably will be very close to having to submit by the time we meet next week, because I think it ends on the 23rd, if I'm not mistaken. So we're on the 13th, so 20th, we have one more meeting and then probably the competition will end. But I think, as I said before, besides our own submission, I'm kind of very interested in the results to see the efficiency results and what all people have tried who are in the top. Good deal. Thanks everybody for joining, and thanks for your links and any further information you gather, please post to Slack, and see you all next week.
Thanks.
Yeah, see you everyone. Bye.
See you everyone. Thanks. Bye. Take care.